We are starting chapter 9. It is applications of trigonometry. Applications of trigonometry, there are very interesting applications, like we can find the height of a tree. Say a tree is there, it is in such a place you cannot climb it, or you cannot measure it by any measuring tape or like that, no? Or the tree is of shape, not proper shape, so how can you find out the height? We cannot climb there, no? By measuring at a certain distance, we can measuring this distance from the foot, we can measure this distance, let it be x, we can measure this angle of sight, and by measuring we can find out the what will be the height of the tree. See, if we know the angle, and if we know this x, x distance, it is on the ground, we can measure it. We don't have to climb to the tree to measure its height. We can just take certain point on the ground and we can measure, say we can take 100 meter, and you can measure the angle, and you can use here tan theta is equal to h by height, capital H, height perpendicular by base, height by 100 perpendicular, it is p by h actually. And if we know this angle, we can find the value and we can find the height of the tree. So there are very interesting applications. Even we can measure the distance of stars in the sky, which were measured at first. Distance of stars were first measured by using application of trigonometry. Okay. And you have to know there are two things here. First is angle of elevation. One is angle of elevation, another is angle of depression. See, when a person is on the ground, not only on the ground, a person is looking upward. Person is here and person is looking something, some object upward. And this, the line joining the eye of the person and the object, this line is called line of sight. And so the person is here, person eye is here, eye of the person. The line through the eye of the person is called horizontal line, parallel to the ground. This is a horizontal line. And the angle between the line of sight and the horizontal line through the eye of the person, this angle is called angle of elevation. So you keep in mind, when a person is looking upward, it makes angle of elevation. And when a person is here, mainly person's eye, person is here, through the eye of the person you draw a horizontal line. Horizontal line always through the eye of the person and parallel to the ground, and person is looking some object downward. Sometimes we are standing on the top of a building, person is looking downward. Then this angle is called angle of depression. When it is looking downward, person looking downward some object, person is here looking downward, the angle is called angle of depression. Angle between the line of sight and the line joining the eye of the person to object, in between the angle is angle of depression. So I'll solve two questions in this video from exercise 9.1. See the first question. Exercise 9.1, first question, solution. You read the question, it is given a circus artist is climbing a 20-meter rope. The diagram also is given here. 20-meter rope, but the rope is inclined at an angle 30 degree. You see, it is given. This is the rope. This diagram also given in the question. Every time diagram will not be given, you have to make it from the question. Person is climbing this way. This is the rope. It is of 20 meter. Person is climbing this way. Inclined at an angle 30 degree to the ground. So if the length of the rope is 20 meter, he has to climb 20 meter at an angle 30 degree. Then what will be the height of the pole? This is the pole to which the rope is tied, and you are asked to find the height of the pole. We can mark it h also. This is the angle. So you see, if this is the angle theta, opposite to angle is perpendicular. This is perpendicular, this is a base, and this is hypotenuse. And you have to find the height of the pole AB. The question is to find height of pole AB. how much it is you are asked to find. So you can use here which angle you see. You have to find this side is actually perpendicular here, and hypotenuse is known. So you have to use the ratio. You remember in this chapter you will use mainly sine, cos and tan. We know in any triangle, angle theta opposite is perpendicular, near is base, and then hypotenuse, and only this three ratio you have to use. Sine theta is P by H, cos theta is B by H, and tan theta is P by B. P by B. Now in this question you see which one is value is there and which one you have to find. That two only you will take. See here hypotenuse is known, it is 20 meter, and perpendicular we have to find it. So hypotenuse and perpendicular, which ratio? Hypotenuse and perpendicular, you have to use this sign here. Base is not there, we do not need also, so we don't have to consider base. So which ratio you will use here? Sin theta is equal to, sin theta is perpendicular by hypotenuse. Sin 30 degree value is 1 by 2, and perpendicular value is AB. AB is height of the pole, we are going to find it, and hypotenuse here is 20. So you see 1 by 2 into 20 is equal to AB. So AB is equal to how much? It is 10 meter. That is, therefore the height of the pole is 10 meter. Height of the pole, that is AB, is equal to 10 meter. So you remember in this question, in this chapter, out of these three, which one you need, you have to select. Like in this question, hypotenuse is there, we need perpendicular, so we are using the ratio between P and H. Sin theta we are using here. In this case cos and tan will be meaningless, and in the entire chapter you will always use sin, cos and tan. Out of these three, maybe any one, maybe two, maybe all the three of some cases, but other three ratio not necessary. Only you will use sin, cos and tan. Maybe all the three, maybe any one ratio, it will do. Now starting question number 2. Question number 2, a tree breaks due to storm. So this is the ground level, you see, it is quite easy. Ground level, a tree, initial height, let it be AB. AB is the initial height, and it is broken due to storm. It is broken here, and this part it is touching the ground at a point, let it be A, B, C, and this point you mark it D. That's it is touching the ground at an angle 30 degree and at a distance 8 meter from the foot of the tree it is given, and you are asked to find the original height of the tree. What is the original height? You can take this side, the BD is say X and AD is say Y. So AD is broken. AD is now, initially it was like this, and it is now leaning there. So this AD is coming now to CD. AD is becoming CD, so length remains same. Say let it be Y. Now in this triangle, you see, you are asked to find the height of the tree. Height of the tree is how much? This whole distance. You see, whole distance is the height. So height is coming X plus Y. That means you have to find the X and Y. X plus Y total below. Okay. Now see, this is the triangle, angle theta here 90 degrees here, opposite theta is perpendicular, near theta is base, and this is hypotenuse. So you have to use once perpendicular and base, because this value is known. Whatever ratio you use, you have to take this value 8, okay, because other value are not there, we know only this value 8. So once we will use P by B, sorry, I am writing wrong here. This is perpendicular, this is base, perpendicular, base and hypotenuse, correct. So once we use perpendicular and base, and again we will use hypotenuse and base. So I am using first hypotenuse and base. If I use hypotenuse and base, I can get the value of Y. If I use perpendicular and base, I can get the value of X, okay. So first I will use sin theta. Sin theta is perpendicular by hypotenuse. Sin 30 value is 1 by 2. What is perpendicular is X. Perpendicular by hypotenuse. No, we will not use sin. Wait. We have to use perpendicular and base. Perpendicular base tan theta. Tan theta is whatever I take, I have to take this value 8. Okay, so perpendicular and base P by B. 10, 30 is 1 by root 3 from the table. Perpendicular is x, base is 8. So I can get x from here. You see 1 by root 3 into 8 is equal to x. So x is equal to 8 by root 3. I got the value of x. Again I have to take another value y and 8. Y and 8 means hypotenuse and base. Hypotenuse and base is cos theta. Cos 30 degree is base by hypotenuse. B by h. Cos 30 value is root 3 by 2. Base how much? 8. Hypotenuse is y. From here we can get the value of y, you see. So root 3 by root 3 y equal to 8 to the 16. Y equal to 16 by root 3. Therefore the height of the tree is the total length A to B is h. H is equal to A to B, and in the diagram you see it is x plus y, and x and y both the values we got. X how much value we got? X is 8 by root 3 and y is 16 by root 3. Just take LCM root 3 LCM is root 3, and 16 plus 8 plus 16 is 24. You can rationalize denominator to get the values. Rationalize denominator like 24 by root 3, both multiply by root 3. So it will be 24 into root 3. Root 3 into root 3 is 3. 3 8s are 24. So the final value is 8 root 3 meter. That is, the height of the tree is 8 root 3 meter.